Good morning, students. Today class we are going to discussing about the problems on. You have to see that the problems on expectation value. Here you can see that in this problem he is giving x be a continuous random variable with probability density function f(x) of x is equal to 8 divided by x cube, where x value is greater than 2. He is asking find E of w. Here the w quantity is x by 3. X by 3. Here what he is asking the expectation of w. Expectation of w. Before going to that, you can able to find in the expectation value of x. Why? We are having the w function, but w is lying in terms of x. That's why here I am first finding the expectation value of x. Why? Here I am writing that solution. The solution of this problem is, here you can write in the given data. Given data is the probability density function. The probability density function f(x) of x is equal to 8 by x cube, where x value is greater than 2. Here what is the value is given? For we can able to find the expectation on w. The expectation on w is equal to, what is the value of w? We are having the x by 3. Here x is a variable and 3 is a constant. That's why we can writing 1 by 3 into expectation of x. In this problem we can able to find the quantity of expectation of x. That's why here I'm writing, in case of continuous random variable, the e of x is equal to integral minus infinite to plus infinite x into f(x) of x into dx. In this formula, what is x value? It is a variable and the required density function is already given in a data. That one is 8 by x cube. In next step, I had to substitute in the limits. The x value is more than 2. The less quantity is at 2. That's why here I am representing the ranges 2 to infinite. Here the value of x is, I am writing as is x into the value of 8 divided by x cube. It is representing the density function. You can writing as a small x or capital X into dx. In this, these either you can write in small x or capital X, both are same. Here you can cancelling x and x cube. The remaining quantities are integral 2 to infinite 8 into x power minus 2 into dx. Here the 8 is a constant, that's why you can write in 8 in front of integration. Otherwise you can write in the outside of integration. You can apply the integration on x power minus 2. Here you can writing 8 into, can apply the integration on x power minus 2 is x power minus 2 plus 1 divided by minus 2 plus 1. Here the limits are 2 to infinite. Now you can writing 8 into x power minus 1 divided by minus 1, the 2 to infinite, 2 to infinite. Now I can writing the above equation is 8 into minus 1 by x, the 2 to infinite. Now I can writing this 8. Now I can substitute the limits. Minus is a common for these two limits. The first quantity is 1 by infinite minus the second quantity is 1 by 2. The 1 by infinite value is a 0. Here the minus into minus is a plus, is a 1 by 2. The total value is 8 into 1 by 2. You can cancel this 8 with 4 times with the 2, as the value is 4. This quantity is representing expectation of x. Expectation of x, but you need the value of expectation w. Here I am writing the expectation of w is equal to 1 by third into expectation of x. Already we are finding the expectation of x value. Just you can substituting here. The value is the 4 divided by 3. This is our required quantity from this problem. What he is asking, he is asking find the E of his expectation of w. Already the w value is mentioning is x by 3. Based on the data we can able to simplifying that. Just you can using the fundamental definition of expected value for continuous random variable. For a continuous random variable, we are writing the formula is like this. In this function, the density is already is given. The function value is 8 by x cube. You can writing in the place of density function. Then you can cancelling the terms is cancelled. After that, you can write in the constants is outside of integration. Then you can applying the integration on variables. After getting the values, we can able to substituting the constants or limits. You can able to substituting in this quantity. Then you can able to finding the value of expectation. Next we are obtaining the 4. Once you can finding the expectation of x, we can able to finding the expectation of w. Why? Already we are able to finding that expectation of w in the form of 1 by 3 into expectation of x. In this relation, we are able to substitute in the expectation of x quantity. Finally, we are obtaining the expectation of w is equal to 4 by third. Okay, students, coming to the next topic. The next topic is a Chebychev inequality. Chebychev inequality. Here, why are you using this Chebychev inequality? This one is mainly using when out to finding the dispersion or a deviation of a curve at a upper bound. It is easy to measure how much of deviation is appear in a upper bound of a curve. We can easy to finding by using the Chebychev inequality. We are having a number of theorems. Among those, the Chebychev inequality is a most powerful tool. It can be unable to calculating the deviation of upper bound. Here, in this diagram, I have to representing one density function. In this density, here I am writing the graph is a bell-shaped curve. Bell-shaped curve. I had to give that. Had to giving the two dimensions a lower and upper. Lower and upper. In this one, the mean value is a fixed one. It is lying at the middle of the curve, and the negative values is a minus infinite. The positive value is a plus infinite. So generally, the density function we are representing with bell-shaped curve. But what is the definition of Chebychev? The Chebychev inequality. Generally, we are having a, for you can consider any distribution function, it is having finite mean and finite variance. But when out to using this Chebychev inequality, what is the statement of here? The statement of Chebychev inequality is, first of all, you can consider x is a random variable with mean m and variance sigma x square. Then for any positive number k, any positive number k. The statement of Chebychev inequality we can able to writing when to taking the assumptions. The first assumption is x is a random variable with mean of m and variance is sigma x square for any positive number k. For this relation, he is giving one equation is probability of modulus x minus m greater than or equal to k into sigma x. K into sigma x. This entire quantity is less than or equal to 1 divided by k square. 1 divided by k square. The second statement is it's a quite opposite to first one. Quite opposite to first one. That one is the probability of x, the modulus of x minus m less than k into sigma x. This quantity is greater than or equal to 1 minus 1 by k square. These are the statements. We can proving this Chebychev inequality. We can able to consider the variance of random variable. The variance of random variable. We can proving this property here. I am consider the variance of a random variable. That one is sigma x square is equal to expectation of x minus m whole square. Already we know that for a continuous random variable we can able to writing the variance is integral minus infinite to plus infinite x minus m whole square into fx of x into dx. Fx of x into dx. Here I am able to finding how much of deviation is done with respect to mean. With respect to mean, that quantity we can able to finding. For that, here I am taking the limits of a integration had to changing into three intervals. Three intervals. One interval is minus infinite to m minus k into sigma x. The terms are same, but the second interval is the same. Whatever the upper limit you can treating here, the same you can writing here in bottom. It is a ending, it is a starting. Both are same. The m minus k into sigma x to m plus k into sigma x. For the function is variance function. Then you can splitting this the third term. The third term is having the upper limit of a second term. That one is m plus k into sigma x up to infinite. The density function and normal variance function is as it is. Here you can give the numbers. The first term, this one is the second term, this one is a third term. In these three terms, the second term is having the fixed limits. The fixed limits are m minus k into sigma x, here m plus k into sigma x. Whenever to consider the fixed limits of any function, the value must be greater than or equal to 0. For this, the second term is having fixed limits. That's why the quantity of second term is greater than or equal to 0. That's why changing that variance formula is sigma x square is greater than or equal to. Why I am writing here the second term is more than or equal to 0. The reason is it is having the fixed limits. Coming to the remaining terms, those are first term and third term. First term and third term, it is having the intervals. It is having the intervals. Those are writing in terms of probabilities. Sigma x square is greater than or equal to. Here I am mentioning the values of x. The higher limit is m minus k into sigma x, lower limit is minus infinite. Here the minus infinite less than or equal to, which value here varying? So x minus, here x value is varying here, that's why you can writing x less than or equal to m minus k into sigma x. K into sigma x, this one is one quantity, plus the second quantity is probability of the lower limit is m plus k into sigma x less than or equal to x is less than or equal to infinite. In these two terms, he can neglect in the infinite values. What are the remaining quantities available? Those values you can arranging. That means the sigma x square is greater than or equal to the probability of capital X less than or equal to m minus k into sigma x plus the probability of m plus k into sigma x less than or equal to capital X. In this one, you can moving the terms. What are the terms? You can changing the position. You can able to writing this function is sigma x square greater than or equal to, here what is the function you can changing? You can moving this m term to x. Why? We are need the term of x minus m. That's why I can writing the probability of x minus m is less than or equal to minus k into sigma x plus the probability of, here you can writing k into sigma x less than or equal to x minus m. X minus m. We can changing this sign to this term. We can writing the sign is a minus and this comparison operator can be changed to greater than or equal. Greater than or equal. That's why we can finally take in the sigma x square is greater than or equal to the probability of modulus x minus m. X minus m, the value is less than or equal to x minus m. Less than or equal to, we can take in the k into sigma x. The remaining thing we have to discuss in next class.